All right, graphing exponential functions. We'll do logarithmic next. I'm doing them in separate videos. But so to graph the exponential function, that's just the function a to the x, where a is any value greater than 0. Okay, we're not going to look at when a is negative. We're just not going to do that one. Okay, so depending on what a is, it's either going to be an exponential growth or it's going to be an exponential decay. So if a is between 0 and 1, which means if a is a fraction, then it's going to be an exponential decay. And if a is above 1, so that will be an exponential growth. This would be a fraction less than 1. Because you can still have fractions that are greater than 1. Okay? So, exponential decay, being motivated and not, then it slowly decays. Exponential growth is when it just starts growing really fast. Okay. All right, so these ones right here are examples of decays, because like 1/4 is less than 1. 0.34 is less than 1. 2/3 is less than 1. 4/7 is less than 1. On the right over here, we have exponential growth. So like 4 is greater than 1. 3/2 is greater than 1. 3 is greater than 1. 5 is greater than 1. Makes sense? Okay, so let's just graph this. And first, this is going to be an exponential growth because it's 2 to the x power. Okay, so we're just going to do this by plotting points. And you can graph literally any function by just plotting points. So we're just going to go from -2 to 2. So when I plug in 0, well, 0 to anything to the 0 power is 1. If I plug in 1, that's 2. So 2 to the first power is 2. 2 squared is 4. 2 to the negative first power, just remember that makes that a fraction. So that's going to be 1/2, and then that would be 1/4. Okay, right here, remember, like if you know what 2 to the first is, you can figure out what 2 to the negative first is. If you know what 2 squared is, you can figure out what 2 to the negative second is. Then we can just plot these. So -2, 1/4, -1/2, 0, 1, 1, 2, and 2, 4. And we can see there that this is an exponential growth. If you keep plotting numbers, the ones on the left are just going to get really, really, really close to 0, and the ones on the right will shoot off to infinity. Okay, so we need to find domain, range, and behavior, the y-intercept, and the asymptote. So domain is your x value, so that's going to be -infinity to infinity. Range is your y value, so that's 0 to infinity. And behavior, so that's going to be as x goes to -infinity, f of x will go to 0. And as x goes to infinity, f of x goes to infinity also. Okay, our y-intercept here is 0, 1. And our asymptote would be at y equals 0, right here. It's where this is like leveling off. So it's leveling off right here. Okay, and that's y equals 0. Let's do another one. So 2/3 to the x power. Well, this is going to be an exponential decay. And then still just go from -2 to 2. If you plug in 0, you get 1. If you plug in 1, you get 2/3. If you plug in 2, you get 4/9. If you plug in -1, that's just going to flip this fraction. So we get 3/2. So if we plugged in -2, we're going to get 9/4. Okay. So then we can plot those. So -2, 9/4. That's like 2 1/4. -1, 3/2 right there. 0, 1, 1, 2/3, and 2 4/9. And there's that one. And we can see that this is a decay because we start really high, but then it gets towards the right, we get really close to 0. So our domain here is -infinity to infinity. Range is 0 to infinity. And behavior as x goes to -infinity, f of x goes to infinity. As x goes to infinity, f of x goes to 0. Our y-intercept is still 0, 1, and our asymptote is y equals 0. Okay, now we're going to move on to transformations. So you've seen these before, hopefully. So if we have our parent function here, a times b to the x minus h power plus k, A is your vertical stretch or compress. So if the absolute value of A is greater than 1, it's a vertical stretch. And if it's less than 1, it's a compress. Okay, and if A is negative, the function is reflected across the x-axis. Now, H is your horizontal translation, and it's always the opposite of what you think. And K is the vertical translation, and that's exactly what you think it's going to do. So if we look at this, we want to identify the parent function and describe the transformation. So if we have f of x equals 3 to the x power plus 5, well, the parent function is 3 to the x, and the 5 is going to move it up 5. This one, so we have 2 times 1/4 to the x minus 1 power. So the parent function is 1/4 to the x. The transformation is a vertical stretch by 2, and it moves right 1. This one, so the parent function is 4/3 to the x power. And then the negative reflects it across the x-axis. The plus 2 moves it left 2, and the minus 7 moves it down 7. Okay? All right, let's look at these. So when we're graphing these, let's first, our parent function is 3 to the x, and our transformation is vertically compressed by 1/2 and up 1. So I'm just going to deal with the up 1 first, and I'm going to draw a dotted line, move it up 1. That's going to represent my transformation right there, up 1, okay? So then I'm going to just do a chart again, so go -2 to 2. And when I plug in, and I'm just using the parent function here, so I'm still just using 3 to the x, so when you plug in 0, you get 1. So this would be like 3 to the 0, this is 3 to the first, 3 squared, 3 to the negative first, 3 to the negative second. Okay, I always make the table on these from the parent function. And now we need to deal with this vertically compressed by 1/2. So the vertical values are your y values because that goes up and down. So that means I just need to multiply all of these values here. Whoa, that was weird. By 1/2. And that will vertically compress this for me by 1/2. So if I do that, multiply them all by 1/2, I get 1/18, 1/6, 1/2, 3/2, and 9/2. If I write those as decimals, it might be a little bit easier to graph. And then we can graph these, and when I'm graphing them, I'm going to treat this as like my new x-axis. Now, it's not really the new x-axis, but since I moved it up 1, that's just where we're going to treat like our 0 as, okay? So then I go -2.056, -1.167, 0, 1/2, 1, 1.5, and 2, 4.5. Now the domain here is -infinity to infinity. The range is 1 to infinity. And behavior as x goes to -infinity, f of x goes to 1. And as x goes to infinity, f of x goes to infinity. The y-intercept, so we can just find that by plugging in 0. Or you could figure out by looking at the graph, like I can see it's 1.5. But if I just plug 0 into this function that I started with, and then simplify that down, you're going to get 1/2 times 1 plus 1, which is 3/2. So the y-intercept is 0, 3/2. And our asymptote is y equals 1. Okay, let's do another one. So 3/2 to the x minus 4 power minus 5. Well, our parent function is 3/2 to the x, and our transformations are right 4 and down 5. So I'm going to deal with the right 4 and the down 5 by just drawing those lines. Then we're going to do our table using our parent function. So 3/2 to the 0 power, or 3/2 to the 0 power is 1, 3/2 to the first power is 3/2. So to the negative first would be 2/3. Squared would be 9/4, and then the negative second would be 4/9. Okay, write those as decimals, might make it a little bit easier to graph. So then this right here would be like my new origin. So we're going to treat this like 0, 0. It's not really 0, 0. This is our real 0, 0. That is the real origin. But just to graph this, we're going to treat it as our new origin down there, okay, to take into account our transformations. So then -2.44, -1.67, 0, 1, 1, 1.5, and 2, 2.25. Domain, negative infinity to infinity. Range, negative 5 to infinity. And behavior, as x goes to negative infinity, f of x goes to negative 5. And then as x goes to infinity, f of x goes to infinity. Our y-intercept, if we plug 0 in there, you're going to get, I just use my calculator here, you get negative 385 over 81, which as a decimal is negative 4.75. And then our asymptote is y equals negative 5. Cool. I'm actually not going to do this one. I think you guys are good. I might go through it in class, but there it is. If you want to look at this one, if you want to do it, and then maybe pause the screen and make sure you get all the right answers here. But that's it. Bye-bye, guys.